Here is something that will make you think about alcohols. The general formula for alcohols is CnH2n plus 10H, where N is the number of carbon atoms. For example, propanol contains 3 carbon atoms. Its molecular formula is C3H7OH. In order to draw this, first draw your 3 carbon atoms. 1, 2, 3. Next, surround them with your 7 hydrogen atoms. So 1, 2, 3, 4, 5, 6, 7. Lastly, add the OH to one of your carbon atoms. To start off with the structural diagram, we can see that prop is given as a prefix of 3. So add 3 carbons, 1, 2, and 3. And then it says add a methyl to carbon 2. So add a methyl, CH3. And now it says on carbon 2 there's an ol. And remember, for alcohol the suffix is ol. So put an OH on the second carbon. And this is our structural diagram. The longest continuous chain, LCC, of carbon atoms containing the OH group is taken as the parent compound, and alkane with the same number of carbon atoms. The chain is numbered from the end nearest to the OH group. Secondly, the number that indicates the position of the OH group is prefixed to the name of the parent hydrocarbon, and the E ending of the parent alkane is replaced by the suffix ol. In cyclic alcohols, the carbon atom bearing the OH group is designated C1, but the 1 is not used in the name. Now, using the IUPAC rules, we are going to name this fully condensed compound. To start off with, we know that there's 10 carbon atoms, so let's label them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Since there are 10 carbon atoms in the longest continuous chain, it makes the compound a derivative of decane, which goes back to rule 1. The OH on the third carbon, which is over here, makes it a 3-decanol, which relates back to rule number 2. The carbon atoms are numbered from the end closest to the OH group that fixes the 2-methyl CH3 groups at the 6th and the 8th positions. So the name is 6, 8 dimethyl, because there's 2 CH3s, dash 3 dash decanol. And make sure there's a dash between 8 and dimethyl. The rules for naming a cyclic alcohol is the same as straight chain alcohols. First, start by identifying the parent chain, which is 5 carbons, 1, 2, 3, 4, and 5. This gives us a first name of pent. Given that the molecule is a ring, add the prefix cyclo. Remember that they're single bonds, so the ending is ane. Since alcohol is the only group on the structure, the suffix of on ol is used. However, the 1 is not needed as it is the only group on the molecule, so forget about this 1. Now we see that the ending ends with ane, so drop the E and change it to ol. You'll get a final name of cyclopentanol. The first class is a primary alcohol, is one in which the carbon atom in red with the OH group is attached to one other carbon atom in blue. Its general formula is RCH2OH. A secondary alcohol is one in which the carbon atom in red with the OH group is attached to 2 other carbon atoms in blue. Its general formula is R2CHOH. A tertiary alcohol is one in which the carbon atom in red with the OH group is attracted to 3 other carbon atoms in blue. Its general formula is R3COH. There are several different types of organic reactions for alcohols. There are substitutions, elimination, dehydration, oxidation, and reduction of alcohol. Primary alcohol is oxidized and H atom remains on the carbon atom, and an aldehyde secondary alcohol is similarly oxidized. The carbonyl group formed is necessarily attached to 2 alkyl groups, forming a ketone. Alcohols. They do not undergo this type of oxidation because no H atom is available on the central reduction of alcohols. Normally, an alcohol cannot be directly reduced to an alkane in one step. The OH group is a poor leaving group, so hydride displacement is not a good option. However, the hydroxyl group is easily converted into another groups that are superior leaving groups and allowing reactions to proceed. Now it's your turn to draw these and name these alcohols. Here are the solutions to the problems. Thank you for watching, and I hope you enjoyed naming and drawing alcohols.